Well, hey there, kiddos. Here is our video on slope applications. So what we're going to do is be finding slope, and then we're going to apply it to a real world situation and talk about what exactly does it mean. So our beginning of this, we're going to talk about rising to the top. So a submersible, which is just like a mini submarine. So a submersible exploring the ocean floor begins to ascend. That means it's coming up to the surface. The elevation, h, of the submersible is modeled by the function h of t is equal to 6.65t minus 13,000, where t is the time since the submersible begin to ascend. So I have a pretty little function. So the first thing it asks is what's the rate of change of the submersible. So we have a couple of options here. We have this function h of t is equal to 65t minus 13,000. The rate of change for any function is going to be the number next to the variable. It's usually an x, but in this case it's a t. And so my slope, my rate of change for this graph should be this number 65 right here. If I use my graph that they've given me, it's a little bit harder to tell because you have really big numbers to deal with. So we're going to just use the function. This is our rate of change, the 65. So our rate of change is going to be 65. Now we have to talk about what that means about the situation. So now here's where our graph comes in handy. So if you look at our graph, we're going to look at the way it's labeled so that we can answer this question. And so the way that it is labeled, and it's kind of hard to understand because this graph is labeled a little funny. I'm going to show you what's going on. So right here, the elevation in feet refers to this y-axis right here. These numbers are actually negatives. This is negative 4,000, negative 8,000, negative 12,000. And the reason why they are negative is because think about the submersible, it's underwater. And so these are all negative values. So it's feet underwater. Up here, over here it says time in minutes. Well, this is referring to the x-axis. The x-axis is actually right here instead of at the bottom, because what's happening is your submersible started below the water and is moving up here to the surface of the water. So the x-axis would be the surface. So to describe our rate of change, remember we talked about slope being the change in the y values over the change in the x values. And so what's graphed on our y values, that variable, is the number of feet that the submersible has risen. And what's on the x-axis is the time in minutes since it started. And so if I'm going to describe what this slope means, remember this is the same as 65 over 1. So what this means is that my submersible rises 65 feet every minute for every 1 minute. So my slope, and I ran out of room to write because I've squished so much in there, but my slope means that this submersible rises 65 feet every minute is what that is telling me. So number 3, how is the rate of change related to the function that models this situation? Well, we already talked about it. The rate of change is this number that's being multiplied by the variable. So with the 65t, the rate of change is the 65 in the function. Now number 4 asks for the domain and range. We're going to call this number right here where this starts as negative 13,000. And then I can see where it ends up here. This is a 20. So I've run out of space for things. And this is going to be 0 feet. So the domain and range, I have to do my domain first, is going to be x values from the left to the right. Well, my x value over here on the left is 0. And my y value over here to the right is 20. So it goes from 0 to 20 minutes. That's what it is covering. It took them 20 minutes apparently to get to the surface of the water. And then my range starts way down here at negative 13,000 and goes all the way up here to 0, which is the surface of the water. So it took them 20 minutes to go 13,000 feet is basically what that's telling me. So I'm skipping the next question. number 5, and it looks like also number 6, but I'm skipping the question about the fish. I find the question about the fish sad. I don't want to talk about dead fish, and so we're going to skip on to number 7. So a small business purchased a van to handle its delivery orders. The graph below shows the value of this van. It's not below, it's to the right. But it shows the value of this van over a period of time. Which of the following best describes the slope of this situation? Well, the first thing I know I need to do is find the slope. So I'm going to use my graph to find the slope of my line. So I'm going to label 2 pretty points. Here is one, and it looks like here is another. And I'm going to draw my right triangle so I can count my rise over my run. Now you have to be very careful here, because if you notice, these little spaces as I go from one block to the next are not increments of 1. They are actually increments of 2,000, because it goes 8,000 to 10,000 to 12,000. So it's actually in increments of 2,000. You're going to have to take that into account when counting your slope. It's going to be negative because this line is decreasing. That's what happens when you buy a car. You buy it and then the value of it decreases instantly. As soon as you purchase it and drive it off the lot, it's worth less. It's just the way it works. So we got to count. This goes down 1, 2, 3, 4 blocks, but remember that's really 2,000, 4,000, 6,000, 8,000. So it is going down by $8,000 for 1, 2, 3, 4, 5 years. Well, let's simplify that so that it's an easier number to deal with. So if I take my calculator and I actually do negative 8,000 divided by 5, I get negative 1,600. Negative 1,600 over 1, or just negative 1,600. And I'm going to leave it this way because I've got to talk about that. The negative means that the value is decreasing. Okay, so it's not A because that doesn't talk about decreasing value, and it's not D because it doesn't talk about decreasing value. Now I've got B and C. Well, B says it decreases in value and C says it increases in value. We just talked about the fact this graph is decreasing, so it has to be B. And if you read it, it says the van decreases in value by $1,600 per year. That's what this means. The negative means it decreases by $1,600 every year. So number 8. The line segment on the graph shows the altitude of a landing airplane from the time its wheels are lowered to the time it touches the ground. Which of the following best describes the slope of the line segment? Again, we need to find the slope. 2 pretty points, so here is one, and here is another. Now, just like with the last graph, we've got to pay attention to our scale. It looks like our scale, every line is 250 on the y-axis, and then on the x-axis each line represents 15. So it's 15, 30, 45, 60, so that you know what your scale is. That's important when you draw your right triangle and you write your slope. So again, this is going to be a negative number, and it looks like it goes down 250 as it went down one space for 30 on the x-axis because it goes over 2. So this is 15, this is 30. So let's simplify that. And to simplify that, I think I'm going to end up dividing them both by 15. Nope. I'm going to divide them both by 6, maybe? Nope. Let's divide them both by 5. That's a nice number. So this becomes negative 50 over 6. And that's going to, if you try to simplify that more, it's actually really kind of blech. So give me just a second. And we are going to actually divide this out, and the reason is because of how our answer choices are. It says 1 foot per 8 seconds, or 1 foot per 2 seconds, or 2 feet per second. So I sort of need to know what this is. So if I divide this out, it comes out to about negative 8 over 1. It's close. It's negative 8.33333333, but we're going to call it 1. So let's talk about units. This 8 is the y-axis, so that's 8 feet. And the 1 is the x-axis, which is seconds. So it looks like it is descending, that's the negative, 8 feet per second. And so if I look, 1 foot per 8 seconds, that's not right. That would have to be backwards. The 1 would have to be on top for the feet. 1 foot per 2 seconds, that doesn't work either. 2 feet per second, that's not what that says. So it has to be D. It descends about 8 feet per second. So we're going to talk this last one. We're going to answer questions 9 through 11. So Tom Thumb Grocery Store has the following sign posted for chocolate gift boxes. Step 1, we need to graph this. So the first thing it asks you to do on number 9 is make a graph of this. And you're going to be estimating because you have decimals here, 4.75, 8.5, 12.25. Go ahead and let's get these plotted. You see down here on the x-axis is gift boxes, so that's x. The cost is on the y-axis. So I'm going to plot these. So I have 3 and 4.75, so it's a little more than 4, not quite 5. Then I have 6 and 8.5. Then I have 9 and 12 and a little more. And then I have 12 and 16. So I have these plotted. I'm going to connect them. Or maybe I'm not. Let's talk about whether or not we should connect this graph or not. If X down here is the number of boxes of chocolates, are you going to buy 1.5 boxes of chocolates? Probably not. That doesn't make any sense. Why would you buy half a box of chocolates? You're just wasting half a box. So really, this should be a discrete graph. So we're going to leave this as discrete data. So I'm not going to connect it. If you connected it, now I made you unconnect it. I'm sorry, Mersal, you'll have to forgive me. So here are our points. It's discrete data. And so for what we're given, it says to determine the rate of change of this situation. Well, I'm going to use my table to do that, and I'm going to do change in y over change in x. So from my table, my change from this for these y values is 375, and my change in these x values is plus 3. So it's 375 for 3, which is the same thing as 1.25 for 1. So the rate of change for this situation, the slope, is 1.25. So what it represents in this problem situation, we'll go back to our variables. The y-axis is the cost, so it's $1.25, and the x-axis is gift boxes, so it's $1.25 per box. It is telling me that the cost is $1.25 per box of chocolates, and that's what it means. So that is the definition of slope. That is, you have to look at what is your y variable, what is your x variable, put it into where you have written your slope, your change in y over your change in x, and have it make sense to say it is going to be $3 for 6 of these, or $1.25 for 1 box of chocolates, or it's losing $1,600 for every year. That's, you need to look at your variables and try and make it make sense. We'll practice this tomorrow, and I will see you then.